In today's video, I would like to introduce a very nice problem of Croatian Mathematical Olympiad edition 2001, question number 3. Here is the following setup. Let E and B be positive real numbers. So our goal, we are going to prove this inequality. We have cubed the root of E over B plus cubed the root of B over A is inferior or equal cubed root of 2 times is multiplied by E plus B and is multiplied by this term 1 over A plus 1 over B. Okay, so maybe there is a bunch of ways to solve this one. So for my method, I'm going to use their convexity and concavity functions. Okay, so in order to solve this one, I'm going to set a function. It can help me to solve this inequality. Okay, go ahead, pause this video if you would like to give it a try to this problem. When you are, come back to see the full solution. Okay, let's get into the solution now. So before I start solving this one, I'm going to remind you about concave and convex functions. Okay, if you have f is a continuous function on a interval, okay, and then we have f prime is a continuous as well on interval ab, and we have second derivative function is a derivative function on open interval. Then if you have the second derivative function is strictly inferior than 0, this one is called f is a concave function. What does mean concave function? If you have this function, for example, I'm going to choose the n interval ab from this function. I'm going to choose two inputs, a as an interval ab, like this. I'm going to take the output of these inputs. I will have f of a and I will have f of b here. Always we have f of a plus b is divided by 2 as an average is superior or equal to f of a is superior or equal to f of a plus f of b is divided by 2, okay, as an average. If I'm putting x0 in this interval ab as an average, so it will be in the half, it will be in the middle, x0. I'm going to take the output of this one. So the output is a maximum of this function, for example, of x0, okay? So also I'm going to take an average of this term. It will be located in the middle of f of a and f of b. Let's take this one, let's call this one as a m, okay? So this one will be replaced by f of x0. This one will be replaced with m, okay? So f of x0 is above m. That means this distance from here to here is bigger than this distance from 0 to m, okay? That means this one is true, is always. This is the tool that I'm going to use for this problem, okay? Let's get rid of this one and join our problem. We have this term. I'm going to distribute this one. It's giving us number 2. A is multiplied by 1 over a, which is 1, plus a is multiplied by 1 over b is giving us a over b, plus the third term b over a, plus the last term is giving us 1, okay? So I'm going to simplify this one. 2, we'll have number 2 here. I'm going to multiply side by side. I will get a squared in numerator plus b squared over the product ab. So by simplifying this one more, I will get 2. I will get a squared plus b squared plus 2 times ab is divided by ab, okay? This one will be written on the form a plus b quantity square over ab, okay? Now I'm going to replace this expression with this value that I found here, okay? So now I will have cube root of 2 times a plus b is multiplied 1 over a plus 1 over b equals the value that I found, which is 2, is multiplied by a plus b quantity square over ab, okay? But I'm going to multiply this one by cubed root of ab from both sides, okay? To see what's giving us. But since I'm going to multiply this one by this one, I have to multiply this one by this one as well. Okay, so we'll get, let's call this one as a capital A. Okay, so we have a capital A equals this one, by multiplying this one by this one, we'll get 2a plus b over b cubed. I put this one inside, is given as a over b like this. So this one is given as cube root of 2 is multiplied by a plus b quantity square. Okay, now I'm going to multiply cube the root ab by this one, the same as I did here. Okay, we'll have cubed root of ab cubed, okay, is multiplied by this term which is on the left side of this inequality, which is a over b cube the root of a over b plus cube the root of b over a. So by multiplying this one by this one is given us cube the root of a square plus cube the root of b square. Okay, by multiplying this one by this one is given us this one, by multiplying this one by this one is given us this one. Okay, let's set this one as a capital B. Okay, so in the last board I was working on this one and came up with this result. We get this one by multiplying both sides by cube the root of a is multiplied by b. Okay, now we are going to prove this one. By proving this one, let's set f of x equals cube the root of x squared, which is the same as x to the 2 over 3. Okay, as we know, let's set x from closed interval ab. F of x continue and derivative function of this closed interval. Okay, let's calculate f of prime of x. By calculating this one is given as 2 over 3 is multiplied by x to the 2 over 3 minus 1. By simplifying this one is given as 2 over 3 is multiplied by x. This one is given as 2 minus 3 over 3, which is x to the minus 1 over 3. So now, since f of prime of x continue and derivative function on closed interval, I'm going to calculate the second derivative function. So the second derivative function is given as this one. This term 2 over 3 is multiplied by minus 1 over 3 is multiplied by x to the minus 1 over 3 minus 1, which is given as minus 2 over 9 is multiplied by x minus 4 to the x to the minus 4 over 3. Okay, as an exponent. As we know, this function is strictly inferior than 0. This one is telling us is a concave function. Because we found this one is strictly inferior than 0, that means is concave function. Okay, now I'm going to apply the concave function rule. So on this interval we have f of a plus b is divided by 2 as an average is superior or equal to f of a plus f of b is divided by 2 as an average as well. Okay, so I'm going to simply to replace this one into this function. So I will have cubed root of a plus b over 2 quantity square is superior or equal to f of a, which is cubed root of a square plus cubed root of b square is divided by 2. Now I'm going to flip this inequality in the other direction. I will have cubed root of a square plus cubed root of b square divided by 2 is inferior or equal to cubed root of a plus b over 2 quantity square. Okay, now I'm going to make this one 4 by taking the square root of this one. I'm going to multiply both sides by number 2. I will get 2 here. Okay, then next thing, if I'm going to take this number 2 inside, okay, so I have to put cube the root here of 3 like this. By putting this one inside become 8. Okay, I will have 8 is multiplied by a plus b square over 4. Okay, this is root cubed. This 8 over 4 become 2. Okay, come to here in numerator. So this one I will have a square cubed plus cube the root of a square plus cube the root of b square is inferior or equal to cube the root of 2 times is multiplied by a plus b square. Okay, now I have proven this inequality exactly that I have here. So now I have done this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.